This is section 9.2, day 2, and we are going to graph roses. Here we have the equation r equals 6 cosine of 2 theta. We're going to take the 2 and we're going to double it, and that's what we're going to count by in the denominator. And what I mean by that is we're going to start with 0. We're going to plug 0 in, and then we're going to count by pi over 4. So we have pi over 4. 2 pi over 4 is pi over 2. Then we have 3 pi over 4. 4 pi over 4 is pi. And this rose, you have to go all the way to 2 pi to get this complete rose. So we have 4 fourths, 5 pi over 4. 6 pi over 4 is 3 pi over 2. Then we have 7 pi over 4, and then all the way to 2 pi. The cosine of 0 is 1, and then 1 times 6 is 6. Then we have 2 times pi over 4. Let's plug that in. 6 cosine of 2 times pi over 4. That's going to be pi over 2. So 6 cosine of pi over 2, that's going to be 0. So we have 0. And then when you plug in pi over 2, you have 2 times pi over 2. Those will cancel. The cosine of pi is negative 1, so we have negative 6. When the 2 cancels out with the 4 and we have 3 pi over 2, that's back to 0. And then the 6 times cosine of 2 pi, when we plug pi in, cosine of 2 pi is 1, so we have 6. And now we kind of see the pattern that develops when you choose the pi over 4s. It goes 6, 0, negative 6, 0, 6, 0, negative 6, and then 0 and back to 6. So let's start with the first point. We have 0, 6. There we go. 1, 2, 3, 4, 5, 6. Then it goes to 0. So it actually curves. It actually curves to 0 like that if we plugged in a whole bunch of points. And then we have pi over 2 is negative 6. 1, 2, 3, 4, 5, 6. And if we plotted a whole bunch of points, it would curve to that one like that. Then at 3 pi over 4, we would be back to 0. So then it curves back to 0 like that. And then pi is 6. 1, 2, 3, 4, 5, 6 right here. So then it curves around to pi. At 5 pi over 4, we're back to 0. So here we are coming back to 0 like that. 3 pi over 2 is negative 6. So going down, we're going back 6. 1, 2, 3, 4, 5, 6. So then it curves around to this one right here. And then at 7 pi over 4, we're back to 0. Back to 0. And then it curves back to 6 at 2 pi. And that should be a nice rose petal. Let's look at this graph on a calculator. We have to go to mode, and we're going to go down to polar. There's polar. And we have y equals, and notice it says R1 now instead of y1. So we can type in 6 cosine of, and we have 2 theta. And notice when we graph it, you have these nice smooth petals. So here we go, graph it. And that's exactly the path that we followed when we did our graph over here, except the petals are, a lot more smooth than what I drew on here. R equals 4 cosine of 3 theta. Well, now we have to plot a little bit more because we have to go by pi over 6. We're going to double the 3. But we'll get a pattern going, and it'll make it a lot easier on us. So we have 0, and then we go pi over 6, 1. 2 pi over 6 is pi over 3. So we got 1, 2, 3 pi over 3 is pi. Here we have r equals 4 cosine of 3 theta. And we're going to count by 6s. We're going to double the 3. So we have 0, pi over 6, 1 pi over 6, 2 pi over 6 is pi over 3. 3 pi over 6 is pi over 2. 4 pi over 6 is 2 pi over 3. And we have 3, 4, 5 pi over 6. And finally we have pi. And when this is odd, this is going to complete in pi. We don't have to go all the way to 2 pi. So we have the cosine of 0 is 1. So we have 1, 2, 3, 4. And then pi over 6 is going to be cosine of 3 times pi over 6. That's cosine of pi over 2, but then times 4. So that's going to be 0. So at pi over 6, we're already to 0. Let's plug in pi over 3. The 3's will cancel. Cosine of pi, when the 3's cancel, is negative 1. So at pi over 3, we're going to be at negative 4. Well, here's pi over 3 right here, so we have to go to 1, 2, 3, and 4 right here. So then it curves around to this point right there. With pi over 2, that'll be the cosine of 3 pi over 2, which is 0. So at 3 pi over 2, we are back to 0. Then 2 pi over 3, the 3's cancel. I guess I forgot to write these down. Let's go with this first one was 4, then 0, then negative 4, then 0. And this will be 4, 0, and negative 4. So we're at negative 4. We went back to 0. At 2 pi over 3, we're at 4. 2 pi over 3 is right here. 1, 2, 3, 4. So then we're to 4. And then back to 0 right there. And when we're at pi, we're at negative 4. So going pi and then negative 4, it goes back to this point right there. So let's look at this on the calculator. We have 4 cosine of 3 theta. And watch the path. Here we go. And there it is. How about 7 sine of 3 theta? We're going to count by pi over 6's. This is odd, so this one will finish in pi. We don't have to go all the way to 2 pi. So we have 0, pi over 6, pi over 3, pi over 2. So there's 1, 6, 2, 6, 3, 6. 4, 6 is 2 pi over 3. Then we have 5 pi over 6. And finally pi, and the graph will finish in pi radians. When that's even, we'd have to go all the way to 2 pi. So the sine of 0 is 0, so we start at 0 this time. Sine of pi over 2 is 1, so it goes 7. Then we have 0, negative 7, 0, 7, and then 0. We're back to 0. It finishes at pi. So we start at 0 with 0, and then at pi over 6, we're at 7. So here's pi over 6. 1, 2, 3, 4, 5, 6, 7 right there. So it's going to curve to that point right there. So we have 0, 7, then back to 0. So at pi over 3, we're back to 0. At pi over 2, it's negative 7. So instead of going up 7, we're going to go down 7. 1, 2, 3, 4, 5, 6, 7 right there. So now we're going to curve to the, that's probably a little too wide. And then at 2 pi over 3, we are back to 0. Right there. Well, that's getting bad. We'll see it on the calculator. And then 5 pi over 6, we're at 7. So here's 5 pi over 6 right there. 1, 2, 3, 4, 5, 6, 7's out here. So we're curving to that. And then when we're at pi, we get back to 0. And then this graph would just keep on repeating. So we have y equals, let's clear this, 7 sine of 3 theta. And let's graph it. Here we go. There's some nice, smooth, more even curves. 6 sine of 2 theta. So we'll start at 0 and we'll count by 4s. So we have pi over 4. 2 pi over 4 is pi over 2. 3 pi over 4. We have 4 pi over 4, and since this is even, we have to go all the way to 2 pi. So 5 pi over 4, 6 pi over 4 is 3 pi over 2. We have 7 pi over 4, and then finally we get back to where we started at 2 pi. But you see this nice pattern start to develop. Sine of 0 is 0, so we have 0. Sine of pi over 2, when the 2's with the 4 would cancel, that's 1, so we have 6. And then it'll go 0, negative 6, 0, 6, 0, negative 6, and end where it began at 0. So 0 is 0. Pi over 4 is 6. 1, 2, 3, 4, 5, 6 right there. And this would curve to this point right there. And then pi over 2 is back to 0, pi over 2. And then with 3 pi over 4 is negative 6. So here's 3 pi over 4. So 1, 2, 3, 4, 5, 6 back here. And so we're curving to this one right there. Pi is 0, so we get back to 0 when we hit pi. 5 pi over 4 is 6. So then along 5 pi over 4, 1, 2, 3, 4, 5, 6, we're right there. And this will curve to this one. 3 pi over 2 is 0, so we get back to 0 at 3 pi over 2. 7 pi over 4 is negative 6, so here's 7 pi over 4, but we have 1, 2, 3, 4, 5, 6 in the other direction. And we're almost done. Then at 2 pi, we're back to 0, and that completes the 4 petals. So when this is even, we have 4 petals, or double the amount of petals, and it finishes in 2 pi. When this is odd, we have the same amount of petals. So let's go back to the odd. This is the same amount, 3 petals, and this one finishes in pi because the coefficient of theta is odd. So let's go back to this one. Let's go to y equals, we have 6 sine of 2 theta. And when we graph it, there we have the 4 petals in the same path that we just took when we graphed it by hand.